Okay, so dear, after that, our next topic is what? Our next topic is hub. Okay, now we will discuss about the inter-networking device. Inter-networking devices. Okay, so what are the inter-networking devices that we are going to discuss? The first
Have the
one is
switch, we have the hub, they have the router,
hub,
we have the
second one
bridges.
bridge.
Yeah.
Okay, bridge. Third one
Switch,
is what?
router,
Switch.
switch, router,
And last one is what?
router.
Router. Very well. Okay. So dear, hub hub is a physical layer device. First of all, hub is a physical layer device. Okay. That is a plug and play device. You just have to plug your cable, and it will start flowing the data. Okay, that is not responsible to whom you're sending the data. Okay, if I talk about the hub is not responsible to whom it is sending the data. First of all, okay, hub is a physical layer device. This is a plug and play device. Okay,
Okay. Yeah.
data will be forwarded in form of what? Bits only. Okay, so it has 2 to 4 ports. Okay, or in simulation you can find the 6 port. Okay, this is a half duplex device. Half duplex duplex device. Now the question is that, dear, what is the meaning of half duplex device?
It's one direction, one direction.
One directional device. Okay, dear, there are three types of devices. First one is
Full
type
duplex, half duplex.
of devices. Okay, first one is simplex.
Simplex, full duplex, and
Simplex,
half duplex.
half, half duplex, and third
And
one is
full
full
duplex.
duplex. Okay, if I talk about the simplex device either send or receive data. Either you can send the data or either you can receive the data. Okay, at the same time. Okay,
At the same time,
yeah. If you okay, at the same time, either you can send the data or receive the data. Like you are using the radio receiver, right? FM
okay, yeah.
receiver. You can only receive the data. That is not
But so
a
it's not at the same time. It's not a
yeah,
two-way, it's not a two-way call. The other person has to finish the communication
yeah,
before you can communicate. Yeah.
yeah. That is not two-way communication. Okay, that is not a two-way communication. Only one side you are receiving or either you are sending the data. Okay, like in radio receiver, you can only receive the data. You cannot send the data, right or not?
Yeah.
Okay, this is something like this. What? This is my sender and this is your receiver. Sender can only receive the data like this. Sorry,
Yeah.
receiver can only receive the data.
You
Okay,
cannot
this is
send.
yeah, this is your sender. It cannot send back any data. Okay, this is the simplex method. Okay, one side communication only. If I talk about the half duplex, what is the half duplex here?
That's the walkie-talkie.
Yeah, walkie talkie. This is your sender and this is your receiver. Okay, if this sender is sending the data, if sender is sending the data and it is taking 5 minutes to send the data, 5 minutes. to send the data. Till the data transfer will be complete, this device cannot send back data till data receiving finished. Okay. When the data transfer will be finished, after that it can, when the data transfer will be finished, after that it can again send the data. It can reply. Okay. If both of devices are sending the data at the same time, what will happen? There will be no data transfer. The devices will be stuck, and that is called collision. Okay.
Okay.
The devices will be stuck, and that is called collision. So at the same time we cannot send the data. Okay. Example, walkie talkie. When one when one finish the data sending, then other can send the data. Okay. Walkie talkie, hub, these are the type of what? Half duplex. Okay. These are the half duplex. Okay. This is simplex. Okay. Now you got the point. What is the meaning of half duplex and simplex?
Yeah.
Now what is the meaning of full duplex here?
Two-way communication at the same time.
Yeah, two-way communication at the same time. Like there are two devices at the same time, they can send or receive the data, right? At the
Yeah.
same time, they can send or receive the data. Okay, so dear, this one, your hub is a half duplex device. Okay, so let us assume we have a hub here. Okay, dear, let us assume we have a hub here. This is your hub. Okay, and this is connected with multiple devices like this: one, two, 3, and 4. Okay, there are multiple PCs here: 2, 3, and 4. Okay, and this is connected like this. So this is device A, this is device number B, this is device number C, and this is device number D. Okay, if A want to send any data to C, if A want to send the data to see what will happen, and we have a hub here, there. Your hub is a dumb device that will broadcast the data to everyone. Every time it will do broadcast, it will forward your hello message to everyone in the network. Okay, what will happen? If A want to send the data to C, it will forward the hello message to every single person in the network. Okay, now, so that is called the broadcast. It will send hello message to B, it will send the hello message to C, and it will send the hello message to D. It will forward the data to everyone, right?
Yeah.
Okay, and and also, if A is sending the data to C, and at that time, what happened? B also send the data. We also send the data that is high. Same time, simultaneously, what? B is also sending the data here. So what will happen, dear? It is sending hi message. It is sending hello message from here. Okay, what will happen? What will happen? Hello?
Yeah.
Yeah, what will happen, dear? If both will send the data at the same time, like this. This is also
If both of
sending,
them send data at the same time,
yeah, they are sending the data at same time. It is sending hello message here, hello message from A.
is
Your
that
hub,
where, okay, will we have a collusion, or is it that the
yeah,
broadcast message will be
yeah,
broadcast to everybody?
yeah. So A is sending the message, B is sending the message at the same time. Okay, what will happen? The both messages will be stuck at the hub, and that is called the hub will stop working, and that is called the collision. Okay, stuck. We can say the device is stuck, right? If at the same time any of the two devices are sending the data, your hub will stop working, and that process is called the collision. Okay, only one device at a time can send the data. Okay, hello,
I'm with you.
yeah. Okay, dear. Once at a time, only one device can send the data. Now come to the third one. Okay. Now what is a bridge? Bridge. Okay. But before that, let me check if we have a hub device or not here. Okay. This is your devices. I think this is your hub, right? This is
Yeah.
your hub, and your hub is connected with multiple PCs like this. You can see this is a plug and play device. After communication, it start working. Okay. Let me give the IP address 192.168.10.1. Okay. And I'm giving 192.168.10.2. Okay. This is 192.168.10.3. Okay. And this is 192.168.10.4. Okay. Let's see what will happen. Let me try to ping any other person in the network. Ping 192.168.10.2. Okay. The packet will be generated, right or not?
Yeah.
ARP request will be forwarded to your which one? Your hub, and hub will broadcast,
Yeah.
right?
Is the ping that is broadcasted?
Yeah, that is broadcasted. Your ARP request is broadcasted, right?
The ping, right?
Yeah. And when your device, your destination is sending back the message, that will again what? Then again it is broadcasting, right or not?
Yeah.
So every time your device is broadcasting, that device was sending a message to this one, but that was broadcasted to other device also, right or not?
Did you state the device you wanted the broadcast to go to? You
Yeah,
didn't state that in your command.
yeah. So other devices also getting the messages, right or not? This is
Yeah, but
your,
you did not indicate where you wanted the message to go to.
yeah. I just want that the reply message must go to source again, right or not? But that message is forwarding to others also. So this device is doing the broadcast every time, right or not?
Yeah.
Okay. This is your source. This is your source. This is your destination, right? So every time, so this is the next message of the ICMP signal, and that is also broadcasted. You can see every time it is broadcasting, right or not? Now
Yeah.
your PC again sending back the message, and again your hub is doing what? Broadcasting, right or not? Everyone is getting the message every time. Again we have a message. It will again do broadcast. Now this is your destination. Destination is giving a reply message. and this will also this reply message will also be broadcast, right or not?
Yeah.
So this device is a dumb device. This device is not that smart to point to check that which is the source and which is the destination. This device forgets every time what is the source and what is destination, right?
Yeah.
So we cannot use these kind of device in our network. Why? Because this is a broadcasting device. This is not that much smart to send the data to correct person, right?
Yeah.
Again, you can see we are getting the next message. It is also again broadcasting. Why it is broadcasting? He also this device also don't know why it is broadcasting because this is a dumb device. This is a reply message to the source. Again, it is also broadcasting to everyone. So we can't use these kind of devices over network. Okay.
Yeah.
And here now we have an upgraded version of a hub. Okay. Which one is that? We have the bridge concept now. Okay.
Okay.
Okay, dear. So bridge is a layer 2 device. It is a layer 2 device first of all. Okay. Now what is the meaning of layer 2? Second one, it can,
It's data link.
yeah, receive or send data by learning MAC address. Okay. It is sending or receiving data by learning what? MAC address.
Address.
Yeah, this is also a plug and play device, but it will work on the layer 2. Next one is what? Single broadcast domain. Okay. So what is happening dear? This is your device. This is your bridge here. Okay. This is your bridge. If we have four different devices like this, we have four different devices. Okay. We have four different devices. And here, let us assume that this is the port number 1, port number 2, 1, port number 2, port number 3, and this is the port number 4. We have different ports in this device. Okay. What will happen here? It will quickly maintain a MAC address table. What? A CAM table. It will maintain a MAC address table like this. Okay. Here we have the port number, and here we have the MAC address. Okay. It will maintain a table like port 1 is connected with the MAC address. Let us assume this device has a MAC address of 0A. Okay. This device has a MAC address of 0B. This device has a MAC address of 0C, and this device has a MAC address of 0 0D. Okay. What will happen? It will quickly maintain a MAC table 0A, 0B, 0B, 0C, and 0D. Okay. Port number 2, port number 3, and port number 4. Here, dear, what will happen if 0A want to send the message to 0B? What? If 0A want to send the message to 0B, right? So what will be the path to send the data? 0A will send the data to port number 1, right or not? 0A will send the data
Yeah.
to port number 1. Port number 1 will send the data to port number 2,
Yeah.
port number 2, and port number 2 will send the data to what? 0
Zombie.
B. So dear, is there any collision possible, or is there any broadcast possible here?
No.
No, because we already have defined the MAC addresses in the table, port and MAC addresses, right or not?
Yeah.
Okay, so let's check that is any well, let's check is any bridge available here. This is your bridge. Okay, this is your bridge here. Let me connect some more devices here. 1, 2, 3, 4. Okay, and let me connect all these. Okay, but dear, you can see that there are no ports available. What? There are no further ports available in the bridge. What is happening? There are, hello?
And with you, are there only 2 ports?
Yeah. I don't have any other ports, right? So what is happening? This device don't have the further port. This device has only 2 ports, like
So it
this.
means it's just a one directional.
Yeah. So that is again a one directional device, right or not? But
Yeah.
but we can do what? We can break the broadcast into 2 parts, right? We can break the broadcast into 2 parts, right or not? Like I can use a hub on the left side and some hub on the right side. That will that will broadcast, the left side broadcast will not go to right side broadcast, right or not? That will be
Yeah.
helpful in that case. Like if I have a scenario like this, uh, this is my where is my hub? Okay, this is my hub. Okay, so I will use what? I will use a hub on left side, hub on my right side. Okay, but here you can also see that I can able to break the parts in. I can only able to break into 2 parts, right or not?
Yeah.
I can make a scenario like this by the help of bridge. I can break into 2 parts. Now broadcast will be into 2 parts only.
So it means you can add other devices on the left and the right, right? From the
Yeah,
hub. Other
left
devices should attach to the hub.
yeah left side devices will not get the broadcast on the right side devices, right?
Yeah.
Let me check, are they getting the broadcast or not? Okay, let's see what is happening here. Okay, give the IP address 192.168.10.1. This is 10.2. This is 10.3, and this is 10.4. Okay, dear. So let me give the IP address. Okay, this is 10.1. Oh, wait a while. Okay, so this is 10.1. This is the 10.2. This is 10.2. This is 10.3. 10.3, and last one is 10.4. Okay, now let's try to ping the devices and see what is happening. Okay, ping 192.168.10.2. Okay, yeah. What will happen? A packet will be generated. ICMP signal will be generated, right or not?
Yeah.
That signal will be forwarded to your hub, and hub will do what? Broadcast, and that message will be reached to my bridge. Okay, bridge will again forward into single direction to the hub again, and hub again to the broadcast, right or not?
Yeah.
And again it is getting back the signal. It will again do the broadcast, right? But
Yeah.
you can see that left side broadcast is not getting to the right side broadcast. If this device want to communicate with this one, Let me check what is happening now. Okay. Ping 192.168.10.4 now. Okay. What will happen? This will be forwarded to your what? Your hub, and hub will broadcast, but that broadcast will not forwarded again. Okay. But it is again forwarding. Why? Because it is learning the MAC address. But now it will not forward the broadcast, right?
Okay.
Only first time this device did the broadcast for the first time. What? Device doing broadcast one time only. One time. Okay. And that is what to learn the MAC address. Okay. Is this device is broadcasting on right side or not? This device is broadcasting the right side or not?
When
No. Right.
after
Why?
learning the MAC address, it does not broadcast the right side again.
Yeah. Now it will not broadcast because first broadcast to find the MAC address, but it will not send the broadcast to the right side. But dear, is it okay to use a two-port device?
A two-port device
Yeah, it is two-port device is good to use.
is not good now.
No, not that is
No,
not good. And it is
it's not good.
is it good to use? It is okay to use the hub kind of device which is
No,
broadcasting
because
everywhere.
this right now, this is when you are doing your network design and
Yeah,
everything. First of
yeah,
all, you have to factor in cost. This is
yeah,
cost. This is cost.
yeah. So
It's more expensive.
these devices are outdated now. That is why we never use these kind of devices. Okay, these are
Yeah,
only increasing my network congestion. Okay,
yeah.
so we
There's no
will
money
not.
anywhere. There's no budget for that.
Yeah, and the main issue is that this is a two-port device. So that is means this table will be only up to two ports only. Okay, it will only learn the MAC address up to two ports. Okay,
Hmm.
so that is means P3 and P4 can't be possible to add here. Okay, so this device is not okay to use. Okay, so which device I will use? Dear, we have more smart device that is called the upgrade version of a bridge. Upgraded version of bridge, that is called switch. Switch is a upgraded version of bridge. Okay. Switch is an upgraded version of bridge. That is means it has multiple ports now. Multiple ports. Okay. It is having multiple number of ports. Okay. Switch is a layer 2 device, but it has multiple number of ports. First one, it is full duplex device. Okay. Second point is that maintain MAC, or you can say CAM table. Okay. Third one is that first
What's come?
MAC address table here. Content accessible memory. That is
What?
called content accessible memory table. That is called MAC address table.
Okay.
Okay. First time it will do broadcast to find MAC address. Okay. Of connected devices. It will do broadcast for the first time to check the MAC addresses of the devices. Not every time. Okay. Every port has separate collision domain. Like there was single collision domain for the complete hub, but here we have for multiple collision domain. That is means every port of the device has different collision domain. Okay. Switch has multiple ports. How many ports are there? That can be 8, 16, okay, 24 or 48. Okay. So we have these numbers of ports. Okay. And the speed 100 Mbps. 100 Mbps ports are there. That is means that is somehow slow. Okay. Because it is having a 100 Mbps link. Okay.
So it's
Hello.
slow.
Yeah, so because it is using 100 Mbps link. 100 Mbps speed is slow. Okay.
Yeah.
Now we have two types of switches. First of all, the layer 2 switch. Layer 2 switch. And this is the layer, and another one is layer 3 switch. What is the difference between these two, dear?
One
Layer
is
3,
the data link layer.
yeah, this switch work on what? Network layer.
Network.
Yeah, on the basis of IP addresses. Okay, that is a combination of somehow router and switch. And layer 2 device is normal switch. Okay, it will work on what? Data link layer. Okay, so now for now we will discuss about the layer 2 switch. Okay, now how your switch is getting the MAC addresses. Okay, so dear, this is your switch now. We have multiple device connected here. Okay, let me connect all these. Wait for a while. One, two, three, four, five, 6, 7. Okay. Let us assume we have these number of devices. Okay, and these are connected with your switch. Okay, there you can see after 30 seconds this is automatically booting up. Okay, these devices are connected now. Now let me check, is your device, your switch has any MAC address or not?
That's the MAC address. Yeah.
No MAC address. Why? Show MAC address table. Is there any MAC address in any of these devices? Can you see any
No.
MAC address? No.
No.
Why? Because we don't have given any IP address to all of these. Okay. So let me give the IP address 192.168.10.1. Okay. So it will start doing the broadcast. Okay. It is forwarding the message to your switch, and switch will do the broadcast, but only for the one time it will do the broadcast. Okay.
Yeah.
Yeah. Now let's check, does it has any MAC address? Yeah, you're getting the MAC address, right?
Yeah.
You got the MAC address on FA0/3. This device send a message to your switch, and it is getting the MAC address. It is learning the MAC address now. Okay. Or let's see about this one. Let me give the IP address 192.168.10.2. Okay, it will again do the same processor. It will forward a packet, and that will be broadcasted, but it is doing the broadcast only for one time. Okay, so this is 192.168.10.1. This is
That's good too.
192.10.2. This is 10.10.3. This is 10.4. This is 10.5 and last one is 10.6. Okay, dear. So let me check, is it getting the message or not? Oh, that is getting the two MAC addresses, right?
Yeah.
So let me give IP address to all of these. Every time 10.3. Okay. Let me give IP address to this one also. 10.4. Okay. This is 10.5. Okay. And last one is 10.6. Okay. And you can see that this is maintaining the MAC address table. You can see all the MAC addresses of all the devices, right?
Yeah.
Right or not?
Yeah. But on
Now
this panel where you chose the device, okay, you chose the switch. Okay, it's fine.
I'm using the switch. Okay. Now what I will do, I will try to ping the devices. Okay. So ping, dear, what is the meaning of ping command?
Ping is to check connectivity.
To check the connectivity and how ping is working. Here, how ping is work. First of all, the question is that. Okay. There are two different devices. Okay. We have a switch here, switch here. Okay. So this device want to send a ping message, right? Ping message has four different packets. What? How much packets are there? Four different blank packets. Four different blank packets are there. That is zero value in every single. There is no value in the packet. Okay. Only the source IP address or destination IP address are there. Okay.
Okay.
Source IP, destination IP. Okay. It has source IP, destination IP, and source MAC, destination MAC. Okay. Okay, dear.
Yeah.
But when we connect a new device, when we connect a new device, we don't know what is the destination MAC address. Okay. So
Yeah. Until you carry out the connectivity the first time.
yeah. But dear, before these packets, we will send another packet. Okay. That packet is called an ARP request. What? Address Resolution Protocol. So first of all, we will send the ARP message. ARP message will have all of these three values, and when it will go to destination IP address, it will get back with an information of source destination MAC address. Okay, it will get back the destination MAC address now. When it will get back, it will have the destination MAC address. Okay,
Is that part of the ping?
yeah, that is the part of it. The ARP message will get back with the destination MAC address. After getting this, we will start sending the packet. First packet will be forwarded to your destination, and that packet will be come back after some time. Okay. Then it will send the second packet and come back. Okay. Dear, the ping command every time will send four different packets. How many packets? Four different packet will be forwarded. Okay.
Four.
Yeah. So let me show you. There are four different packets. Real time. Okay. Let me show you four different packets are working. Okay. When I will press enter, you can see first packet, reply from the first packet, reply from the second packet, third packet, and the fourth packet. Right or not?
How about the AR, how about the ARP?
ARP will not show here. Let me show you where is the ARP message now. Okay. ARP message will be show here. Okay. I will show you ARP message here. Okay. ping 192.168.1.3. But your ARP message will be forwarded one time. After getting the MAC address, it will not flow the next time. Okay.
Yeah.
What is this? This is your ARP message, right? Right or not?
Where?
Here you can see this is your ARP message, ARP request.
Okay.
This green one is the ARP message. Okay. Does it has any destination MAC address? This is source MAC address, but it don't have any destination MAC address. Can you see any destination MAC address?
No.
It has the source MAC address, right? Source IP address, target IP address. One thing is missing, that's the target MAC address.
So the TTL, the time to leave, you are saying that the TTL.
Yeah, the TTL value is also here.
So what is it supposed to do? The TTL, the time to leave.
The TTL value is the maximum age time of a packet. For how long packet
the
will
aging
remain?
time.
Aging time
right?
of the network. Time to live. Okay.
Yeah.
This ARP request will be forwarded to switch. Okay.
So Niraj, you're supposed to give me kudos because a lot of these things I already have idea of my own.
Okay. So you already know about all this, dear.
No. I'm just saying that you're supposed to give me kudos.
Yeah, I will send you. I will give the recording of this one. Okay. Okay. So you can see still it doesn't has any target MAC address, right or not?
Yeah.
And when it will be forwarded to the devices now, every device will discard that message, right or not? But one is accepting. Everyone is discarding, right? The cross signal here. But one is accepting. This one is accepting the data. Now you can see we got a target MAC address, right?
Yeah.
Right or not?
Yeah.
Did we have the target MAC address?
Yeah, there's target MAC address there. Yeah.
Yeah. Now we just get that message, right? If we check the previous packets, we don't have the target MAC address. But for now we have the target MAC address. Now it will get back the message again. The switch will get the message. Now switch has the source MAC address, destination MAC address, source IP and destination IP, right or not?
Yeah.
And it will be again get back to the same one. Okay. Now ARP request has done. After the ARP request, I told you what will be forwarded. The message will be forwarded into four different parts, four different ICMP messages. Okay. Ping message is called ICMP message. Okay, dear. ICMP message. The ping command is known as the ICMP message. It is checking the connectivity. Okay. What? So ICMP message is equal to what? Is equal to what? Ping command. Okay. And what is the meaning of ICMP message? That is internet control
messaging protocol.
Message protocol. Okay. Internet control message protocol. Now my question for you, that is very important question, because this is 0. This is a null message. So is it a part of TCP or UDP?
0 UDP.
So you're talking about the UDP. ICMP message is the part of UDP, right?
Yeah.
No. ICMP,
okay, no. Since you're checking connectivity, it's supposed to be TCP.
No, that is not the TCP. That is not the UDP. Only this is a null message that has a separate domain. Okay, that is a separate domain. Okay, that is not the part of TCP. That is not the part of UDP. That is the part of what? ICMP. Ping command is the part of ICMP. I already have written here. Okay.
Okay.
So we have three types of messages, three types of protocol to transfer the data: TCP, UDP, and
TCP and
ICMP.
ICMP. Okay.
ICMP is called the null message. Okay, to check the connectivity on it. Okay.
Okay. So that's all. That's part of transport layer then.
Yeah, that is also the part of that. Okay, we can say, but we don't know. We don't mention that in transport layer because this is a null message there. There is no information here in ICMP. That's why that
Okay.
is not the part of TCP or UDP. Okay,
Okay.
that is part of ICMP. Okay, that is to check the internet connectivity only.
Yeah.
Okay, dear. So
Yeah.
now you can see what will be the next packet. Next packet will be an ICMP signal. We have sent the up message. After up message, we will send the ICMP message. But ICMP message will not be broadcasted. Why? Because we have the
MAC
destination
address.
and source MAC addresses. Okay,
Yeah.
dear. So ICMP
Yeah.
signal directly forwarded to your PC, and PC will get back the message. Okay. Now you can see that this we got the first reply from the destination. Okay,
Yeah.
like we got four reply. Now we have get the first reply. First ICMP signal has been received. Now again it will send back the next ICMP signal. It will check four times, like I told you here, that it will check the message four times. Okay.
Yeah.
Yeah, so we got the second one also. Check. Let me check.
What are we ending to this class?
Yeah, this one. We got the second one also, right? Now it will send the third one. After some time, it is sending the third one now. Okay. And third one will be forwarded to your PC and will get back again after some time. Okay.
Okay.
Now talk to the last one. This is the fourth message. Okay. And that will be forwarded and received. Now you can see all the messages has been received. Okay.
Yeah. When are we ending to this class? To this class?
What, dear?
When are we ending to this class?
Yeah, after some time here.
Because I just want to take some. I want to take like 10 minutes break.
Okay. Okay. So you want to take a break of 10 minutes?
Yeah.
Yeah, you can take the break. Okay.
Okay.